We're going to talk about sums and differences as they are used in geometry. One place we see sums and differences a lot is when we're dealing with angles. For example, a complementary pair of angles might look like this. When you put them together, they form a right angle, so they add up to 90 degrees. Any pair of angles that adds up to 90 degrees is a complementary pair of angles. 40 and 50 degrees, for example, are a complementary pair. We could say that the complement of a 40-degree angle is a 50-degree angle. A supplementary pair of angles might look like this. When they're put together, they form a straight line, so they add up to 180 degrees. A 130-degree angle plus a 50-degree angle would make a straight line. They're a supplementary pair of angles. Another place is in the angles of a triangle. You probably already know that the triangle sum theorem says that all angles in a triangle add up to 180 degrees. So those are three places where sums of angles are going to be important. Some symbols that we use when dealing with angles and triangles. The symbol for a triangle is a triangle, and we write it in front of the name of the triangle, so it would be triangle ABC. That would refer to this object right there. The symbol for an angle looks like this. We'd put it in front of a vertex of the angle. Angle B. That's referring to that object, the yellow object that's an angle formed by two rays. The measure of an angle, the symbol for that puts an M in front of the angle symbol, and we might use that to say something like the measure of angle B is 115 degrees. So a couple quick examples. Number one is a right triangle. There's also a 30-degree angle in it, and we're supposed to find x, the missing angle. So we know the three angles of a triangle add up to 180 degrees. So we write an equation to represent that. 30 plus 90 plus x equals 180. Combine like terms. Subtract 120. X equals 60. But there's a more efficient way to think about this particular situation, or any right triangle situation, because we know that the right angle takes up 90 of the 180 degrees. That means the two smaller angles, the two acute angles, must add up to 90. They're complementary. So 30 plus x equals 90. Subtract 30, x equals 60. So that gets us to the answer in a more efficient manner. In number 2, that's not a right triangle, but we have the three angles are 120 degrees, and x plus 10 degrees. We still know they add up to 180 degrees, so we write that as an equation. We can combine like terms. X plus x is 2x, 120 plus 10 is 130. Subtract 130 from each side. Multiply by 1/2. X equals 25. And we can check that, because if x is 25, then x plus 10 is 35, and those three angles should add up to 180 degrees. And they do. For number 3, we do the same thing. 2x plus x plus 30 equals 180. I don't actually need those parentheses because we're just adding, and order doesn't matter when we add. Combining like terms, 4x plus 30 equals 180. 4x is 150. X is 37.5 degrees. So, not a whole number. But still, we should check, because if x is 37.5, then x plus 30 would be 67.5, and 2x is 75. We add those three up. They do add up to 180. Check. Good luck as you work with angles and triangles.